The next 3 slides are on intermolecular force practice, so I'm going to walk you through the first example and then I'm going to have you push pause and see if you can figure out the rest of the examples. So our first example is dissolving candle wax with kerosene. So remember, we have 4 intermolecular forces, so what we want to do is decide what we have present. So our ion dipole force is a salt and water, and so in this case we do not have either of those two, or a salt and a polar molecule, so neither of these are an ionic bond, so it definitely can't be an ion dipole. Our second intermolecular force, based on strength, is a hydrogen bond, and so I'm going to look and say, do I have any hydrogen bonds here? Do I have any molecules with a hydrogen and then a nitrogen, oxygen, or fluorine on another molecule? I don't, so it's definitely not a hydrogen bond. My third example is a dipole-dipole force. So my third intermolecular force is a dipole-dipole force. So then you ask yourself, are these non-polar molecules? So think about it this way. Candle wax and kerosene. So neither of these would actually mix with water. So if I know they're not going to mix with water, I know that they are not polar molecules. So they're non-polar molecules. So there's no way, if I've got 2 non-polar molecules, I'm going to have a dipole-dipole force. My last example, or my last intermolecular force, is a London dispersion force. So London dispersion forces acts on 2 non-polar molecules. Candle wax is a non-polar molecule. Kerosene is also a non-polar molecule. So because of that, this interaction would be considered a London dispersion force. Alright, so I want you to push pause and walk yourself through those examples for the rest of these practice problems, and then push play again and I'll walk you through my explanation. Okay, so hopefully you tried the rest of these, so let's look at ethyl alcohol absorbing into your bloodstream. So we're going to go through the 4 intermolecular forces again. This is my recommendation in terms of answering these questions every time. So, ion dipole is my strongest intermolecular force. That one is between a salt and a polar molecule. So, ethyl alcohol and blood are neither a salt. So, it cannot be an ion dipole force. So then the next one you look at is a hydrogen bond. So, does ethyl alcohol have a hydrogen attracted to a lone pair on nitrogen, oxygen, or fluorine explicitly for the example for the blood? No, so it cannot be a hydrogen bond. So then you look, do I have 2 polar molecules present? Well, yeah, alcohol is a polar molecule, so anytime you have an OH group on there, and blood is also a polar molecule. So I can stop there and I can say, because I have 2 polar molecules, I know I have a dipole-dipole force present. Let's look at the next one. Iodine gas molecules condensing into solid iodine. So I'm going to ask myself, start with ion dipole. So ion dipole is my strongest intermolecular force. It is between a salt and a polar molecule. So iodine is not a salt. Iodine is not a metal and a nonmetal. So iodine gas condensing into solid iodine cannot be an ion dipole intermolecular force. My next intermolecular force is a hydrogen bond. So iodine does not have a hydrogen present in the compound. So there is no way that this can be a hydrogen bond. My next intermolecular force is a dipole-dipole, and so a dipole-dipole is between 2 polar molecules. Because iodine is a diatomic molecule, it is nonpolar, so it cannot be a dipole-dipole force. My last intermolecular force is a London dispersion force. Iodine is a diatomic molecule, and I know that it's a nonpolar molecule. And so the intermolecular forces acting on nonpolar molecules are indeed London dispersion forces. So because it's interacting with another iodine molecule, it's 2 nonpolar molecules, so this is London dispersion. Okay, hopefully on this next slide you took the time to actually go through and try these as well. If you didn't, go ahead and pause the video and try these ones as well. So, detergent removing gravy from a garment in water. So this one's kind of tricky, so if you didn't get it, that's okay. So basically what you're looking at is that there's actually 2 things present here. Okay, and this is why detergent works. Detergent has a nonpolar end, and that nonpolar end will actually dissolve the nonpolar fats and greases that might be considered present in a stain. So the detergent's nonpolar end would be dispersion forces. The detergent's polar end would be ion dipole, because it would be the detergent and water interacting. And most of the time the detergent is going to have an ion present in there to be considered that. So this one's kind of a far-fetched example, just trying to show you that more than one intermolecular force can be there. Okay, so dissolving table salt in water. So we're going to go through our intermolecular forces practice. So table salt is a compound that's ionic. So when I look at my first example, an ion-dipole intermolecular force, that is any time you have a salt in water. And so because I have table salt in water, I can stop right there, and I know that this is an ion, and this is a polar molecule with water, so I have a salt with water, and I know that I have an ion-dipole force. Alright, let's look at sugar in water. So I'm going to start at my first intermolecular force. If I've got an ion, if I've got a salt in water, I know it's an ion-dipole force. Well, we know sugar is a covalent molecule, and so there's no way that this can be an ion-dipole. My next intermolecular force is a hydrogen bond, and so I know that sugar does not have a hydrogen attracted to a nitrogen, oxygen, or fluorine on the water molecule. So I know it cannot be a hydrogen bond. I know that sugar, however, is a polar molecule, and I know that water is a polar molecule. So my next example, or my next intermolecular force, is a dipole-dipole, and because both of these are polar molecules, this is a dipole-dipole intermolecular force. Alright, lastly, let's look at the strength of intermolecular forces. So table salt versus sugar in water. So because I know that table salt in water is an ion dipole from our example, and I know that sugar in water is a dipole-dipole, I know that the ion dipole is going to be stronger than the dipole-dipole because my ion dipole intermolecular force is much stronger. So dissolving iodine and oxygen in water, which is going to be stronger? Well, because they're both nonpolar molecules dissolving, it's going to be dispersion forces, but iodine is more polarizable, which gives it a larger dipole, and so that makes it have a stronger intermolecular force. Okay, thanks for watching the example problems and writing it down. Hopefully you can come with questions to class next time.